Welcome to video 0.2 for another look at conversions. This is maybe more complicated problems just to give you a little bit more guidance on conversions if you need it. 3 problems on this video to discuss. So first, if a person takes a 12-minute shower with a faucet that uses 2.5 gallons per minute, how many milliliters of water will a person use during the shower? All right, let's get started. With the conversions method, 12 minutes is the shower, and it will use 2.5 gallons per minute. So if I'm looking at a question, this is a helpful skill. If I'm looking at a question and I see the word per, 2.5 gallons per minute, this is a conversion. And I can put the gallons or the minutes on the top or the bottom. It doesn't matter. I use minutes on the bottom because that's what I needed in order to cancel my conversions. I need to convert to milliliters. So I'm thinking, all right, I know that 1 gallon is 3.7854 liters. This is not a conversion you would need to memorize. And I also know that 1 liter is 1,000 milliliters. That is a conversion you should know. So gallons canceled, liters canceled. I have milliliters, and that's what the question is asking. So I'm done. I just need to bring out the calculator and do the math. Multiply the top, divide by the bottom. So I have 12 times 2.5 is 30 gallons for the course of the 12-minute shower. And each of those gallons is 3.7854 liters. And each of those liters is 1,000 milliliters. So I have 113,562 milliliters. So 110,000 milliliters rounded to 2 significant figures. That's question number 1. Here's one for you. A box in your backyard is full of sand with a density of 5.9 grams per milliliter. You measure the box to be 2.25 feet wide by 3.50 feet long and 1.67 feet high. How many pounds of sand are in the box? So the first thing we need to do is figure out the box volume, which is length times width times height, which is 2.25 feet times 3.50 feet times 1.67 feet. And I didn't necessarily put that in the order of length times width times height. I just knew that I needed to multiply all 3. So 2.25 times 3.5 times 1.67. I get 13.15 feet cubed as the volume. Oh, sorry about that. That was a bit weird. 13.15 feet cubed is the volume. I'm keeping 4 significant figures here, even though I only need 3 for this answer, because I want to just keep extra significant figures until the end. So let's move to the next slide. 13.15 feet cubed. And I need to somehow get this into either centimeters cubed or milliliters cubed. So I know that 1 foot is 12 inches. So if I cube those, and I know that 1 inch is 2.54 centimeters. So if I cube those, I know that 1 centimeter cubed is 5.9 grams. So this is the conversion that came from the question. And I know that 453.6 grams is 1 pound. So now I can do the math. You might consider cubing these values first before you do the math. So 12 cubed, for example, is 1,728, because that's 12 times 12 times 12. 2.54 cubed is 16.387. So in terms of doing the math, I'm going to multiply 13.15 times 1728 times 16.387 times 5.9, and I'm going to divide by 453.6. I get 4,843.39 pounds. I need two significant figures. So I need about 4,800 pounds of sand to fill that sandbox. That's a lot of sand. The key here, as with all of my conversions, is to cancel my conversions at every step and finish with the conversion or calculate the unit that was needed for the question. A solid with an irregular shape weighing 17.94 grams is added to a flask with a volume of 25.35 milliliters. It is found that 8.35 grams of benzene must be added to the metal to fill the flask. What is the density of the metal? Okay, this is weird. Kind of an involved problem. Let's think about it. Density is mass over volume. So grams divided by milliliters. I know the mass of the solid. So I need to find the volume of the solid. And so what we've got is a graduated cylinder of some sort, a flask of some sort, that has a volume of 25.35 milliliters. And this piece of metal was put into the flask, and benzene was added to the flask. And 8.35 grams of benzene was added. And that filled the flask. So, if I know the total volume of the flask, if I can find the volume of the benzene, I can subtract the benzene and find the volume of the metal. So that kind of gives us an idea of where we might go forward. So I know that I have 8.35 grams of benzene, and I know that benzene is 0.879 grams per milliliter. So I have 8.35 divided by 0.879. I get 9.50 milliliters of benzene. So I had a 25.35 milliliter flask. It took 9.50 milliliters of benzene to fill that flask. So 25.35 divided by minus 9.50. I have 15.85 milliliters remaining, which is the volume of the metal. And I know that density is mass over volume, and the mass is 17.94 grams. The volume was 15.85 milliliters. So I have 17.94 divided by 15.85, and I get 1.132 grams per milliliter, because I can keep four significant figures. So that was kind of an interesting problem. We had to really think about the information that was given in the question and how we could use that to solve the problem. That is the end of this video to help you with conversions and dimensional analysis, as some people call it. Check your answers as you go, as you work through that worksheet. It's quite a few problems, so differentiate. Decide for yourself, how many of those problems do you need to do. Don't tread water. Don't do problems just because. But of course, let me know if you have any questions. I'm happy to help you. Thanks for listening. Have a great day.